Okay, so in this video we're going to talk about marginal revenue and marginal costs. Alright, so let's start with the definitions of marginal revenue and marginal cost. So marginal cost, denoted MC with a bar over top, is the derivative of the cost function with respect to the quantity. And it estimates the cost of producing one more unit. All right, let's look at the definition of marginal revenue. So marginal revenue, denoted MR with the bar over top, is the derivative of the revenue function with respect to the quantity X. And it measures the approximate revenue generated by selling one more unit. All right, let's do a couple examples. So we'll call the first example example 1. Let's let the revenue function as a function of quantity be negative 1 over 20 x squared plus 100x. And in this problem, we're going to find the revenue function evaluated at 501 and subtract the revenue function evaluated at 500. And then we're going to find the marginal revenue evaluated at 500. Okay, so let's start by evaluating this function at 501. So R of 501, negative 1 over 20, 501 squared, plus 100 times 501. This is going to work out to be 37,549.95. R of 500 is going to be, if we evaluate it using our calculator or our computer, 37,500. So the difference of those two values, difference between those two values, is going to be $49.95. All right, so now let's look at the marginal revenue evaluated at 500. So first we got to compute the marginal revenue. It's just the derivative of the revenue function with respect to x. So negative 1 over 20 times 2x, derivative of x squared is 2x, plus 100 times 1, which is negative 1/10 x plus 100. Now we'll put in 500 into this function. We'll get negative 1/10 500 plus 100, which is negative 50 plus 100, which is 50. Okay, so you can see that the marginal revenue is really similar to this difference above. Let's look at a graph to illustrate the relationship between these two quantities. Okay, so if we draw the revenue function, it's going to have a peak at 1,000 and zeros at 0 and 2,000. And the peak corresponds to an output of 50,000. Okay, now we're looking at the point 500, so here's 500 to the left of 1,000. So we put in 500, we get out 37,500, so 37.5K. And we put in 501. I'm going to exaggerate the difference between these. let's just call it R of 501 here. Okay, so what we're measuring in the part A, in the first part of this problem, is the change in our revenue as we go from 500 units to 501 units. So if we zoom in on this, let's zoom in here. Our revenue function is going to go up between these two values. It's going to go up. As we go over 1 unit, it's going to go up. So this amount that it goes up is $49.95. In part B, however, we found the slope. Okay? So what that's measuring is how much the tangent line goes up as we go over 1 unit. That's the change in the tangent line as we go up. So you can see that the tangent line slope is approximating the increase in the function as we add 1 more unit. In other words, the marginal revenue is approximately how much the revenue goes up as we add 1 more unit. All right, so let's look at another example. This one will involve marginal costs. Call this example 2. So suppose the fixed cost is $6,000 and the variable cost to produce X units or X items is 10 root X. We want to find the marginal cost to produce the 2,501st item. All right, so first we're going to construct our cost function. So the cost function is the fixed costs plus the variable costs. The graph of this function looks like this. It's going to have a y-intercept of 6,000, and then it's going to increase in a square root fashion. And you might notice from this graph that the marginal cost is going to decrease as we go further out. In other words, the more items that we've produced, the less expensive it is to produce 1 more item. All right, so let's compute the marginal cost. So the 6,000 is going to be 0. Then we have to take the derivative of 10 root x, which we could write as 10 to the x to the 1/2. So using the power rule, this is going to become 1/2 x to the negative 1/2, which we could rewrite as 5. 10 times 1/2 is 5, x to the negative 1/2, or 5 over the square root of x. All right, so to find the cost of producing this 2,501st item, we're going to put in the value 2,500. And the reason is the increase from 2,500 to 2,501 is what we're interested in. And to find that increase, we got to find the derivative at 2,501. Okay, so we're going to put 2,500 into our marginal cost. We'll get the square root of 2,500 in the denominator. That works out to be 50. If you take the square root of 2,500, you get 50, which, if we do division here, we'll get 1/10 or 0.10. So as we go from 2,500 to 2,501, the increase in our cost is about 10 cents. All right, I hope you found this video useful.